Hey guys, welcome back to the Makefile series. We're finishing up the Make Essentials section, and the objective by the end of that section is to understand everything that you need to write a makefile, a functioning makefile. Towards the end of this section, which is where we are now, we're learning more about things that are less essential but still worth knowing. And the topic for today is wildcards. Now, we're going to approach that from 3 or 4 different perspectives. And the first part of that is a last resort default rule, which doesn't really fit a wildcard, to be honest, but I think it's in the same vein and it's worth mentioning. So let's talk about that. What that is a percent, so a pattern rule with double colons. And GNU Make calls this a last resort default rule. This is not anything different than a normal pattern rule. It might have special optimizations in the make program itself, but really it does what you expect it to, where if you run the make file and you pass in something that's not a target already, it matches this rule over here. So we print out the target name and we print out the prerequisites. This is a rule that I'm actually going to use later in this video, which is why I wanted to show it first. And now we can move on to the more interesting parts, which are first off, the shell function, but we're going to use this to implement a wildcard. So the shell function, we actually used it previously, especially when talking about recursive variables. But we'll formally define it here as a function that runs the specified arguments in the shell and evaluates to the string that the arguments print out as they're executed in a shell. So I'm going to take this over here. I'm going to run that, and whatever this evaluates to, whatever gets printed out over here, is going to be what this expression evaluates to. So shell mk function is going to have all of these as its prerequisites, and the shell c function is going to have this as its prerequisite. So we don't have any C files here, so it's not going to have any prerequisites at all. Let's try running that. And I'm just going to run the top level target, which depends on both of them, so it'll run both. And we can see that the first one has all of these prerequisites, but the second one doesn't have any prerequisites at all. Now, it's very important that when you run a shell command, you know what directory you're going to be executing in, or you're agnostic of the directory, or at least you're aware of the implication of changing directories. Now, we see this result if we execute this makefile in this directory, but if I move up and I go to another directory, so in a previous video we had the simple C project and we have C files over here. If I run that makefile using the relative path, make f.3 9, and then if I run the same rule, now I see the C files as the prerequisites, but I don't see any makefiles, .mk files as a prerequisite. So when you run the shell command, it is going to inherit your current directory. Be aware of that. Also, if you put this shell command in a recursive variable and you use that recursive variable in different environments or different contexts, again, you could get different results. That could be something you want, it could be something you don't want, but you have to be aware of it. This construct over here is the typical way to have a wildcard implemented. It's the most straightforward way to dynamically figure out what files there are that follow a certain pattern. So you might see this used, or you might use it yourself, but if you would like, there is a built-in wildcard function. In fact, there are two options. There's a glob, which is just a star dot whatever you want, or you can put stuff before. Or there's the wildcard function that takes the same expression. So what's the difference between these two? I have 4 examples over here, 2 of them using globs, 2 of them using functions. And let's run it and let's see. We have a top level wildcard target that runs all of them using some fancy add prefix magic. And let's run that from the directory that has C files. So we'll run the same makefile and we'll say wildcard. And we see here, first off, star.mk has prerequisites, empty. What does this mean? Where did this come from? We'll get to that in a moment. Wildcard mk glob has prerequisites star.mk. Whoa, what happened here? It looks like this was evaluated literally. So it literally said, I want a file that's named star.mk. And I don't know about you, but I would never make a file with that exact name. So this is kind of weird. And that is why we actually created, or we ran the rule to create star.mk, which is the rule from over here. So if I delete this, actually, we'll probably just get an error. And yeah, we see no rule to make target star.mk. So this might not do what you want it to do. The problem is sometimes it does. Let's look at the C version, and over here we see that the C glob actually has the .c files as its prerequisites, and it acts the same as the wildcard function. We have the same result. So that's the problem. If you use a glob and there are files that match it, it's going to expand or evaluate to the files that match. But if there aren't any files that match it, it's going to stay as the literal. And that's why you should always, always, always use the wildcard function, so that if there are no matches, you're just going to get the empty string. In the case where there are, you're going to get the same string. So everything is going to work just fine if you stick to the function. Now, let's move back to the original directory and let's make some directory and touch a file in there, something.mk, and let's run that again, and let's say wildcard. We have a problem here. So we know about the glob problem, but what happened to the wildcard functions? It evaluated to the mk files, but unlike, let's run the shell version. Unlike the shell version, which saw dir1/something.mk, the wildcard function did not go down into this other directory. It didn't check anything else. It only checks the current directory. So that is one of the missing features of this wildcard function. And in fact, there is no recursive wildcard function built in to make. So to get around that, you actually can define your own function, which is something that we discussed in the previous video of using call and sometimes eval to evaluate your own variable as a makefile function. And that's what I did over here. This is my own implementation. There are better implementations of a recursive wildcard online, and there is some links to that down here below. But what we can do is we can call our own function and pass in .mk or .c, and it will go recursively into other directories and it will check them as well. So let's give that a shot. And wildcard mk has these prerequisites and it sees dir1/something.mk. So don't worry, you can use or you can create your own portable recursive wildcard implementation. The one you see here, I wrote it, I thought it was fairly simple to understand, but it probably has a lot of edge cases it doesn't cover, like spaces or, you know, passing in multiple multiple extensions to match. So the other options, there's a Stack Overflow question, but even better than that, there is a GNU Makefile development kit, basically, from Mark Piffer, which has two very powerful functions: a search down function, which is pretty similar or the same as what we have here, or a wildcard recursive function, which supports very advanced globbing. So these are definitely worth a shot if you're interested in having a more powerful wildcard. So that's mostly it for this video. Before ending, I do want to mention wildcards in makefiles are a controversial topic. I believe the CMake recommendation is to handwrite the files that you want and to avoid using a wildcard to dynamically figure out which files you want to build. And that's something that I feel is, I don't like doing that. I like to write my makefile and move on with my life. But there is a very strong school of thought in that direction. So you might not ever need this stuff. You might want to handwrite your files. And ideally, when you're writing a nice makefile, you're only going to have to write that file in one spot anyways. So it's not a whole lot of work to track the files that you're building. But wildcards is still useful. They're still worth knowing. So I hope you gained something from this video. Thank you for watching and hope to see you next time.